calculators with you?
No, I don't.
Yeah.
Unfortunately, I need to buy one.
Can everyone who holds a calculator right now? Can we have calculators? Because I think we agreed on that we are going to solve some problems.
Yeah, unfortunately, but I can use on the cell phone. I can use the cell phone one. It's fine. Let's see.
It can't work.
The cell phone.
Do you think it's gonna work?
Yeah, I got a scientific on the cell phone.
Calculations which you are going to do, I don't think they're gonna allow us to do that.
I'm not
All
sure.
right, Mina, I collected mine and I'm ready.
Okay.
I'm ready now. I'm waiting for you. Let's hear from the rest. It's a good evening, but now remember we agreed that we are going to look at space in Spain. And on that note, we have some questions which we shared last time. Those are the ones which we would like to look at right now. And I believe that's maybe possibly this is going to help us. Quintila, how are you?
Find yourself.
Yes. I believe that you are doing well. Do you have a calculator there with you?
Yes.
All right. So I think I like people to have calculators because nothing we can do without calculators. So I think I'm going to bring the first question which we are going to solve right now. I'm going to bring that question right now. I think it's sometimes healthy to have these questions, we read them together, then we see what you can do. See what you can do. Onward.
Yes, how are you, sir?
I'm good. Is everything okay?
Yeah, now everything is in order. My head is fine.
What was the problem? What was the problem with the head?
Remember last time when I came to submit the assignment?
Yes.
Yeah, the very same day when I came back to Rustenburg, we were involved in a terrible accident.
Oh no.
Oh, that's why you didn't come for exam.
Yeah, I couldn't write in November. I couldn't write in July. I couldn't write in November because, like, I lost everything: the phone, some of the books, and the calculators, everything. Even my passport.
That's terrible. Right. So, very sorry, my brother. Now, look, I think. Sorry. I shared the question on our group there. Right now, as you can check, there's a question. It's one of the questions which we shared, and I'm trying to make sure that everyone is on board, right?
Okay, I can see.
Straight. So I'm going to read the question. All right. So I'm going to read the questions, then we analyze them. We see the data wanted, data given principle, conversions where necessary, we also do that. But now, three main types of. I think we have.
Cancel confession share.
The group I'm saying that particular question doesn't need us to stress because we have direct stress, shear stress, bending stress, etc. There are many. Right, I think everyone is fine with that question. Let's go to 6.2 because this is our main question. Onward, are you there?
Yes, I'm still here.
Onward.
Yes,
All
I'm
right,
here.
I'm going to make sure that everyone is all right, I'm going to make sure that everyone is participating. I'll ask each and everyone to share with me whatever you understand. Right, so the question reads as follows. We are going to mark keywords. A steel rod with a length of 350 millimeters and a diameter of 20 millimeters is compressed on both ends by a force, and it becomes 0.2 shorter in length. Right, so you have your steel bar, you press it, right, both sides. So possibly it shrinks, something like that, it becomes shorter in length. That's basically what they're saying. The following results were obtained. Sorry. Calculate the magnitude of compression for 80 gigapascals. So basically, let's put the information down. The data for that. LO, which is the original length of our rod, steel rod, is 300 and what?
And 50.
350. Then convert it to meters. Divide the 350 by a what?
1,000.
By 1,000, which is going to give us 0.35 meters, if I'm not mistaken there. Then the diameter of our rod originally, it is given as 20 millimeters divided by 1,000 to convert it to meters, gonna be 0.02 meters, right?
Yeah.
L, which change in length is 0.2 millimeters. So when you convert it to meters, it gives us what? Convert that one with the calculator.
Divide by 1,000.
It gives us what?
2 times 10 to
It
the
gives us
power
what?
0.0002.
Those are meters, which is changing in length, right? Are we agreeing that that is changing length, right?
Yeah.
Why are you keeping quiet? Right. So there's a formula in N2, N3, which says change in length is equal to LO, which is the original length, subtract what? Actually, it's change in length is equal to a mass of the object multiplied by specific heat capacity, which is HSC, multiplied by delta T, which is changing temperature, right? That one we're not going to apply it, but I wanted people to know. Then we also have the Young's modulus, which is E, given as the 80 gigapascal. By the way, giga is 10 to the power
Of 9. Is it 9?
Good, that's correct. Yeah, which is 80 multiplied by 10 to the power 9. Now these are now pascals. Onward, are we together there?
Yes, correct. Is 10 to the power 9 giga.
All right, now if you say 8 multiplied by 10, 8 multiplied by 10 to the power 9, it's going to be Pascals. Right. Now, before we move on, now I said people must go and do more thorough research on these questions. But now, to my understanding, if my memories serves well, I'm going to make a reference in our talk. I will check where necessary. But for now, what I understand is that young modulus E is given by a strain over stress. No, am I correct or I'm wrong? I'm correct, right?
Wait, what did you say?
I'm saying young modulus E is equal to strain over stress, right?
No, it's stress over strain.
Or it's it's equal to stress over strain, right? That's good. No. Thank you very much. That's correct. It is stress over strain. Now, but
Yeah, sorry. My camera is off. Hello?
Ja, want die ding is nou, hierso. Is nou goed wat belangrijk is. Hoe werk jy compressive stress en strain? Ja. Hy het niks daarvan genoem nie. Hierdie het ek nou by daai ander ou gesien. En dit is toevallig jong modulus. Die stress over strain. Ja. Okay. Nou moet jy weet hoe werk jy. Okay, so hierso is stress, né? Ja.
I think we lost the lecturer there.
Yeah, I don't know what happened.
Strain. Hierso is sy formule. Hierso is stress se formule. En hierso is force se formule. En dis al wat jy heeltyd gebruik. Ja. So, dit moet mense aan die boek gaan kyk. Al die formules.
yo, what's going on, network?
I don't know.
Guys, all right, anyhow, it's fine. Let me return the question once again, right?
Tensile compression.
Let me return the question. This thing, man.
Ek het gesê direct stress, die shear
Alright, let me return the question.
bending stress.
Dit is 'n stongel. En as jy stres is wat dit skoon is.
Nou jy sien wat ons nou uitwerk is direct stress. Hierdie ene tensile en compressor. Dis waarmee ons nou besig is.
Jy net tensile.
Ja, en compressive.
All right, wait, 2 minutes. 2 minutes. I'm gonna be showing you this question. I just want people to have the question so that when we are, what we're gonna be doing, we're gonna be
Sien,
making
hulle sê
reference to.
vir tensile en compressive stress is dit die calculation. Maar daar's baie goed wat bykom.
Which is the. Right, thank you. All right, the question is there. So I'm saying strain is equals to what? Give me the formula to calculate strain. Hello.
Yeah, strain is
Equals to?
change of length over original length.
That's correct. So if we say E is equal to stress over strain,
Die verskil
this is the same as saying we are saying
oor die
F
original.
over A
Ja, ek weet nie waar is
over L
Soek dit.
over delta what?
vir jou byt.
L over what? So now we can expand this formula to say
Kan jy
change in length in that particular formula. Change in length, if you make change in length with subject of the formula, then you're going to remain with the formula which says F multiplied by LO over E, which is Young modulus, multiplied by what? Multiplied by A, which is area. That is the formula which I want. I'm going to share with you this formula right after we push a bit. Right. So now we are told to calculate the magnitude of the force.
Kan ek vir iets verduidelik?
Which means,
Ja.
hello? 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 Right. So I have the formula which says, let me write it here, which says delta L is equal to F over E multiplied by LO over A.
Die
So I want everyone to take this formula. Right.
F
The formula says F
nee, dit
delta L is equals to F over E
ek het nog nie hom
multiplied by LO over A. Right. But as now we are told to calculate the F which we are seeing at that point. Right? So if we make F the subject of the formula, this is going to give us F is equal to delta L multiplied by E multiplied by A all over L O. Are we together? That part there?
Correct.
Right. But now, this is a cylindrical material which has the diameter of 0.02. So possibly, if you want, you can separately and say A is equal to pi d squared over 4. Then you can get the answer for area. After that, we substitute things which we should do. So I want you to punch the. Let me come back and say let's calculate the area separately. What is our area? Calculate the area.
Pi d
Los
squared
die
is
eerste formule.
0.0
Ander ene sal ons kyk nou.
squared.
Want die ding is ek weet nie of staan die
What is the answer?
Die vir my is baie meter.
ja, maar dis klein deel. Let me see what's the word delta L seker.
Yeah, it's the change in length. Kom ons maak so eerder.
The answer is 3.141 of numbers.
All right, the answer is equals to, speak aloud, my brother.
3.1.
3.4195.
Yeah. At the end, there's a times 10 to negative 4.
All right. So now, in other words, if I can put it nicely, if
Okay.
Kijk, hoe kom ik hier de lijst terug? Het geeft ons een volgende examen. Maar het werkt niet. Dan krijg je nog gecheckt ook. Maar het is baie goed. Ga je aan Google geleerd YouTube. Wat baie meer. Ja, dat gaan jij doen, niet? Wacht, even kijken.
all right, guys, there was a disturbance here. So what I'm saying is that let's put it this way, to say this is going to be, if we substitute our values straight, then this is going to give us a, I want to write it here, F, sorry.
Iets anders dan.
This is going to give us a, this is written first, 1 second.
Okay.
All right. This is going to give us a,
Wat het ons nou?
F is equal to 0.0002 multiplied by 80 multiplied by 10 to the power 9 multiplied by, you said 0. What there? You said 0. Hello? Hey, let's talk, Mr. Guys.
Ja, ek het nie weet om geantwoord nie.
All right, our area we said is 3.4195. So multiply by 3.141. 3 point what?
141.
All right, what is our answer?
Do you want the answer?
Area? Yes.
Yeah, the area was 3.141.
Yeah, it's fine. Can you punch everything and give me the answer?
Correct.
Onward, what is our answer there?
I think I made a mistake on the area of the cylinder there.
All right,
said
can
it-
you punch?
You said it's pi d squared over 4.
Yeah, which is going to be pi multiplied by
0.02
0.02
squared.
squared over 4.
I don't know, my calculator is giving me 0.000314.
It's correct.
Okay.
It's correct. Right now, I want, because the idea is for us to see how do we calculate the force, of which now our final answer for force is equals to
we're gonna maintain the original length, which is 0.350.
Dan daai diameter.
yes,
Then
yes.
take delta
Hy moet in millimeter wees.
delta LE.
Which is
Daai
0.0002.
kom nou net meter toe glad.
Exactly.
Sy kry nou.
We multiply
Maar
that
maar
by
sê hulle
area and
weer
divide by the
0.3.
original length.
Hulle gaan mooi daai bedrag.
Which is 0.35. What is the answer?
Ja,
Yeah.
maar jy sien, dit is wat my volgende probleem is. Nou kan skryf jy eksamen.
Quickly, what is the answer there?
Reg. En hulle merk dit verkeerd.
En ek wou nee, kyk die memo sal hulle
Ja.
dit kom van die departement. Maar
All right, what is the answer, my brother?
3.0.
Yes, yes, yes. Hello?
my answer was 14.361 kilonewton or
14 point
14,300
what?
14.361 kilonewton.
All right. Yeah, which is correct. Which is correct.
Yes, there is one thing
And the
that
other
bothers
guys,
me.
what?
Sorry.
Yes.
The diameter, that should be in millimeters and not meters.
It should be
Yeah.
meters.
Our diameter should be in meters.
Remember
Agreed
the
there.
SI unit of length.
Madam, are you good there?
The diameter is supposed to be in meters.
Okay.
Yeah, that's correct.
Yeah,
That's correct.
everything in millimeters must be converted to meters.
Well, the thing is,
Right.
okay.
Yes.
No, it's fine.
Yeah, talk mention, it's fine.
Now, what I read up is that with stress and strain, the diameter needs to be in millimeters because it's a
That's right.
standard engineering calculation, they said. So,
Right, for because once you do that, you need to make sure that because they are using the millimeters against some other newtons, against some other units. So you need to make sure that your units are in what we call basic SI unit, which means that the basic SI unit of length is meters.
yes.
It's not kilometers. It's not in millimeters. It's not centimeters. Right?
Yes.
So also our if you can check on our young modulus, it is given as 80 gigapascals, but we converted it to what? To pascals. And pascals is SI unit of what? Of pressure, which is force.
Yes.
One it's in kilonewtons now. It's no longer basically we can't use kilonewtons in calculators unless everything is in line with
Okay.
that. Then you can work with that kilonewton.
Okay.
Right? We don't want to waste time with that one. Let's move on to number 3,
Yes.
6.3, which says the following results were obtained by means of a tensile test on a carbon steel rod. The original length is given. The original diameter is
As jy daar nou 'n meter gaan
Goeie man.
as jy daar nou 'n meter gaan sit, gaan jy raai 14 punt sal uitkom.
Yo,
Think that
please, what's happening here?
think that more.
Your phone. Sorry.
Network. Onward, what's going on here?
I don't know.
Yo, maybe it's network possible. Can be
Yeah,
network.
I think that you stole the cables that side.
Smoking down there 56 kilometers. Is that what I say?
Really. All right, so I was still carrying on with the action, but now the thing is, we do have the force at limit, we also have load, which is equal to 10 kilonewtons. Then calculate the stress at limit of proportionality. Also, that one is have 3 marks. Also, the modulus of elasticity of this piece. Right. Now, only 6.3.1, stress is equals to F over A. Is that fine? Is that okay, guys? Can you speak aloud so that you can, yes. So, yes. So our since we must calculate the stress at limit of proportionality, the force at limit of proportionality is 98 kilonewtons. So this is going to be 98 multiplied by 10 to the power 3, or 98,000, over the area. The area at the limit of proportionality, once again, it's given as the diameter is equals to 40 millimeters. So this is going to be pi, our area is going to be pi multiplied by 0.04 squared over 4, right? Which is going to be giving us our formula. So this is going to be 98,000 over 5 multiplied by 0.04 squared over what? Over 4. What is the answer to that one?
You said 98,000 over
98 over pi multiplied by 0.04 squared over 4. What is the answer to that one?
98,000.
Yeah?
Can you repeat your formula? 98,000 over.
All right, remember, we need to, this is very important. The question says calculate the following: the stress at the limit of proportionality. Then our basic formula to calculate stress, it says stress is equals to F over A. And our F is equals to 98,000 over area. It's going to be pi multiplied by 0.04 squared over 4, which is the same as saying stress is equals to 98,000 over 0.04 squared, then multiply by 4.
Can you confirm something for me? I just want you to confirm something for me. Do we always have to use meters and not millimeters?
Exactly. This is what the net was saying. Pitler was also talking about it now.
Because I used millimeters and I see.
What is your answer when you use millimeter?
When I used millimeters, I got an answer of
Yes.
77.986.
You get what?
77.986.
Multiply by what?
No, I got it. The false is 98 times 10 to the power 3, or I can just write 98,000.
Yeah.
And then the area, because I used 40 millimeters, 40 squared over pi times 40 squared over 4, which gave me 1,256.637.
Your area is supposed to, you said pi multiplied by what?
by 40 squared.
40 squared.
It's supposed to be 0.04 squared.
It will never give you that answer if you use that. If you multiply, if you say pi multiplied by 40 squared over 4, it will never give you the answer which you're giving me right now.
40 squared. I got the diameter as 40.
Check it. Yes. 40 millimeters. Can you punch it nice?
Well, you want me to double check my area?
The answer which you are having there, it's what?
Or the final one. Okay.
When you say 98,000 over pi multiplied by 40 squared over 4, what is what?
Okay.
Yes.
The answer is 77.
What about Quinty? What is your answer? Quinty, what is your answer?
No, I haven't found that answer. My calculations is incorrect.
But what is what? Okay. What about onward?
I'm getting 3,119.42959.
When you use the what 40?
No, when I use the 0.04.
So you're saying in other words, that is your area where it works. That guy is getting the correct answer, which is the 77.986. Those are megapascals. But now I wonder how is he how are you calculating this? Because your answer is what it has to be in megapascals, but you say it pascal.
It's about root.
Give me the answer of your area separately.
Okay. Of millimeters. When I use the millimeters and not meters.
Use millimeters and use meters.
Okay. When you
Give me
use
those two answers. When you use area in meters and area in millimeters.
Okay. If millimeters, the answer is 1256.
1256.
Yeah, point.
633. All right. What about in meters?
In meter.
It's gonna be 12.6.56. Yeah?
Let us check.
Because in meters, you're saying pi multiplied by 0.04 squared over 4. What is the answer?
1.256.
1.256. Right. So let's do it. Let's say the first one, let's say 98,000 over 125.6.637. Give me the answer for that one. Then the other one is 98,000 over 1.256. What is the answer for those two? The first one is what?
The second one is 78,025.477.
When you say 98,000 divided by 1.256, you get what?
78,025.
78,025. What about when you say 98,000 over 1.1256.637?
Okay, 98,000 over 1.
Over 1256.637.
77.637. Then I get 77.986.
Yeah.
But if you round off, maybe it will be 77.986.
77.986.
Yeah.
The other one is 78. The other one is 77.
Yeah.
So where are the discrepancies there?
78.0024.
Eh?
992638.
You get what?
78 dot 78,00024,992638.
For
So
when you
I
use
think it's
1.25. The answer is 78.
1256.37.
No, you said one.
When you use 1256.37, that's where you get 78.
You get
7.00.
Die rede hoekom
Seven
hulle
ze-
daai
seven
app
eight.
is, en hulle weet
I
hoe
think-
gebruik.
I think both answers
Aan
are
die ou
correct.
einde van die dag moet jy hierdie
Okay.
eenheid gebruik.
All
Nou
answers
hoekom
are
wil ek dan 'n
correct.
meter hier wees? Wat ek weer op 'n manier moet
Yeah,
gaan
because that's what
omskakel.
I'm getting
Yeah.
also here.
Newton.
All answers are correct.
So when
Ja,
you use
dit is
millimeters and
megapascal.
we are all correct.
Yeah, because
So-
now the one
Hoekom wil ek dan hierdie
for
meter
meters
gaan maak? En dis
is
wat hulle nie vir ons sê op die internet.
78.025.
Dit is dan waar jy
The
moet
one
werk.
for
Presies net daar.
millimeters
Millimeters.
is 77.9
En dis hoekom hulle
something.
sê daai moet bly.
Yeah.
Daai
Yeah, so
But
I think both
but
of them.
Lou,
lengte.
Yes,
but
Hierdie
Lou, I think
Moet-
the tricky part now
Pascal
is to
en
know
meter
how to
wees.
develop from one formula to the next one. Then it will be easy for us in any question.
yeah, because this
So
is
it
the
will be
reason
easy
why
for us to memorize because I don't think when I
Waarom moet
are we gonna
jy
have access to formulas?
Hierdie ene.
yeah, formulas are there in the book, but the thing is that now in the question,
No,
but the
during
thing is
exams.
that
I'm talking about during exams.
yeah, they're gonna be there. But my question is that now
Okay. Yeah.
because let's check what the examples are given like in our
Okay.
textbook. Then we try to follow because that's why I'm using the data given, data wanted method. Because otherwise you can argue up until tomorrow. Let's
Hierdie mos dan no.
answer 6.3 popularity of the test piece, of which I think E is equals to stress over strain, right? So we have calculated our stress. Some will say 77.986 over our strain. Our strain, we already have our strain, right?
Was strain.
Our strain is equals to what?
Strain is 9.25 times 10 negative 4.
Strain is equals to what?
So it's equals to X. Wait.
Remember we said the strain
Change of length
is equals to
over
original length over what?
No, change of length over original length.
Sorry, change in length over original length, which is equals
Original
to
length.
delta L over
Original
L. Yeah. So our original length is there is equals to what?
16.
Okay, our change in length anyhow is equal to 0.0555 multiplied by 10 to the power minus 3 if you put it in meters.
Werk hulle ook net in millimeter.
Then our original length is 0.06. Then I think this one is the one which is giving us what we are saying there. This one was easy, but provided now you get 6.31 correct. Right, I wanted us to look at another question because it seems like we dwell too much on this one, right?
Yeah.
Let's look at another. Yes. Let's look at another question because I think there were 3 questions. I
mean, hoekom begin hy nou nie? Ek weet nie eens nou hoekom met een eenheid. Hoekom begin hy nie dat sê okay, hierdie een is so, daai een moet in daai eenheid wees. Hierdie een moet in daai eenheid wees. En dis die een ding wat ek my wou gevra want ek weet nie wat se een eenheid.
Right, these questions are more or less the same, né? Right. We have that question which says a roundabout with a diameter of 30 millimeters and a length of 0.9 meters is machined 2 millimeter size over in the square section is not to exceed 350 megapascals. Calculate the stress in the roundabout. Calculate the stress in the roundabout. So I think this one is it's not that tough. It's not that tough, right? We are given the diameter of the bar, which is 30 millimeters, which we can say we want 0.03 meters. We are given the length, which is 0.9 meters. Then it's machined to a square of 15 millimeters, say 0.015 meters. Am I correct there?
Machine is machined to have a square. Okay.
Yes. Then over a length of 0.35 meters. Once again, the stress is not to exceed. So right now, the maximum force, calculate the stress in the roundabout. Right, we are saying stress is equals to F over A. But now, what we should calculate there, which is not given, is the force. Because our formula says the stress is equals to F over A, right?
Yes.
Yes. So we should get the force. So how do you calculate the force?
You multiply.
Yeah?
If we are given the
pressure over the area.
If we are given the pressure, then we can say force is pressure is equal to force over area. So we
That's
make
good.
Meter.
Yeah.
En nie met millimeter nie.
Right, so F is equal to stress multiplied by what?
Area.
By area.
By area. So what is our area there in that particular question? What is our area?
Area. 15 times 15 per square.
It's pretty.
So we are saying go to say.
You moet my daar.
Say.
So this is gonna be 350 multiplied by 10 to the power. Multiplied by 10 to the power 6 multiplied by 0.0 multiplied by, this is square. So the area of the square is equals to What?
Side by side.
225.
15 square.
So this is going to be 350 multiplied by 10 to the power 6 multiplied by 0.015 multiplied by 0.015 once again.
Yeah.
Yes. So what is our answer?
Okay, you let's just I lost the writing.
Yes.
You said what?
We are saying you told me to say area stress is equal to F over A, right?
Correct.
Then
if
you told me yes, talk.
Then if you want to find force,
yes,
we multiply
okay.
stress by area.
Right. So stress is provided as 350 megapascals, which we say this is going to be 350 multiplied by 10 to the power 6 multiplied by area. The area now, this thing has been manufactured to 15 millimeters. So this is going to be 0.015 multiplied by 0.015. Then we get the force there.
Correct.
What is our force? What is our force? Hey guys, calculate what is the force. Yes. What are we getting? Our force? I'm stuck. I'm waiting for people to tell me the answer. Quickly, what is the answer?
7.875.
7.875. 7.875. Those are kilonewtons, right? Those are kilonewtons.
Let's see.
Which is going to be 7
kilonewtons.
Yes.
Okay. Then we 7.875 Newton.
Which
no,
is
this
7
kilonewtons.
Okay, let's put it as 7.875 newtons.
Exactly. Yeah. Then it's in newtons.
Yeah. Because if you say 7, because I was thinking that you're teaching us, now you're converting it.
7
So
points.
our F, all right. So our F is equals to correct. Now let's calculate the stress in the round bar. So stress now is equals to F over A. The same formula. If we calculated it, we have. Now what we need is to calculate the what? The diameter. Of which the diameter there is going to be 0.03 pi multiplied by the, yes, it's going to be pi, our area is going to be pi multiplied by 0.03 squared over 4. Then you get the answer. Then after getting that answer, you are going to say 78.50 over the answer which you get as your area. What is the answer? What is the answer then?
That's 0.02355.
Check it again.
You say, did I make it? multiply by pi.
No.
No. Okay. I'll check again. Let me just go.
API.
Three.
Let us
What's wrong for?
Gigakas calcium complex now.
0.00007065.
With the API degree.
That's what?
That will be
area.
the straight.
The area.
No, isn't the area square multiplied?
Oh, guys, you're confusing me. Our answer for yes.
Okay, millimeter. Yeah, to be the area, but now
Get it straight. It's 4 marks. These marks are too much.
0.00065.
All right.
It's 0.705 meter.
What about the stress now? What is the
answer? Can you let me review?
All right, guys. Can I do this? Let me send the answers to the group, right?
Yeah.
Yes.
Well, I think other people want to go to other lessons. Let me send the answers for all those questions there to the group.
Then I'm going to send the question and answer.
Yeah,
thank you.
Can you please send the question and answer?
After this lesson, I'll be doing another topic.
All right.
I'm saying, can you go to hits? Then, while you are still on hit, I'm going to send more questions for stress and strain right away.
Sure.
But with the answers.
Okay.
Okay, good.
Thank you
very much.
Bye.
Let me transfer. So now what we are going to do, I'm going to send the answers for these questions, our homework. Then we check where we are making some errors, etc. Then after that, I will send more questions.
Okay.
Then you look at the answers. I've got paper, then the answer down, question paper, answer down, question paper, answer down, one after the other. If I send the 5 different question papers and answers, you're going to be fine on this particular topic. After that, I would like you to go and look at what it hits. I would like you to go and look at it.
Are we going to prepare it for next?
Thank you.
For next lesson.
All right.
All right, sure.
Okay.